Okay, I'll continue. So this is the sort of default opening screen for DBmarlin. If for those who've seen DBmarlin before, you will have seen this screen before. It's got a list of the instances ranked by the busiest first. So in at number one, we've got DB2 on cloud, and somewhere in the list there is SAP HANA in at what, number six. You can obviously order things by whichever one of the columns you like. As I say, that's been there for a while, but we've obviously plugged in a SAP HANA instance. So if we go to settings, we'll have a look at how it's set up. So there it is. So if we edit its settings, we've called it SAP HANA. Strictly speaking, it should be SAP HANA Express because that's all we've actually tested against. I mean, we're really looking forward to getting ourselves hands-on to something a bit more than just Express. We've installed it somewhere locally. So there's its IP address. We have to tell DBmarlin what type of connection we're going to be dealing with. So in this case, it's a SAP HANA one. But as you can see there, we've got a number of database technologies that we support these days, and slowly but surely the list grows. There's the port that it listens on, connection details, system, and a password. We're using the sort of default settings for most of these. So we're not using the advanced, but if you were to click on the advanced, you could see more details. You could customize the JDBC URL if you wanted to. You could change the timeouts. We're sampling once per second is the main monitoring interval, but we also have within the tool a sort of background batch process, as we call it, that is currently sampling at once per minute. But you can change these. I mean, these are just the default values of, but you can either make it faster or slower depending on your requirements. As I say, we're just leaving it with the default settings. I haven't actually mapped this SAP HANA instance to a particular host, but we could have done. It could be sitting on one of these hosts, in which case you can make an association, which is quite powerful later on when we look at sort of CPU utilization and so on of the host. And we haven't at the moment created any third-party links for HANA, but we could do. And it's just basically you give it a name, and then you give it a URL, and then that'll appear. And I'll show you later on where that might appear. But it's shortcuts. An obvious one would be a link into Instana, but you could link into the the AWS console or anywhere that you fancy. And tags, we have just introduced tags in the last month or so. So you can basically name value pairs that are associated with this instance. So you might say the environment is test, and the app is something to do with SAP, and then these name value pairs. Exactly how you might expect tags to work in any product. But at the moment we've not really got those set up for this instance. So that's the sort of settings. I say the most important ones are things like the name, the IP address, and the username password, and the rest of them down here are sort of optional ones that you can set up if you want to. Before I move into the the main screens, I'll just show you one other sort of admin screen, which is the SQL statistics. And so for SAP HANA, you can actually have lots and lots of statistics that you could collect if you want to. We currently enable 85, but we'd actually only chosen 6 of them. But if if you're really keen on, I don't know, max execution fetch time, you could click it and say, right, that'll be collected. And I'll show you later on where if you were to click all these, where they would appear. I'm not going to enable them for the moment. But we just collect a standard sort of subset, things like duration, execution, CPU time, because they're generally useful, we find, but the others are optional. So let's go back now to the database instance screen. And if we now pick on, actually, before I pick on SAP HANA, I just want to show you how we've tried to make everything very consistent and homogeneous. So if I go into DB2 just very quickly and just look at the layout of the screen, you'll see that we have some summary information at the top. Sorry, we've got some tabs, things like activity, group statements, statistics, and so on. Some summary information, a graph, some donuts, and a list of statements ranked by the most important at the top. And if I do the same for the next one, say Oracle, it'll look incredibly similar, which is a set of tabs, activities, statements, statistics, and so on, a graph, donuts, and a list of statements ranked by the slowest first. And so if I come and choose SAP HANA, you will be amazed to see that at first sight, it looks pretty much identical to all the others. And that is obviously deliberate, and is part of our sort of plugin architecture, is that we create a sensor for each new technology. And as long as we provide the callbacks that the sensors expect to find, then everything else kind of you almost get for free in the UI, because as long as it conforms to the sort of standard template, then you get the set of tabs, which I'll go through in a minute, summary information, a graph, donuts, and a ranked listing of statements at the bottom. So let's just have a look at this screen in a bit more detail. So we're looking at the activity screen. So this is based on our sampling. We're sampling it once a second, and we're seeing what is going on. And we've got the sort of the total effort time being recorded here and the total number of executions over time. We're looking at the last hour, but obviously you could, if you wanted to, change the time period. We can actually break that down by some other criteria. So we could sort of see which statements contribute over time. So we can see that the purple one, the number one statement, is definitely the dominating statement. We can look at wait events. So this is what is the system waiting on. So for example, is it running? Is it waiting on a semaphore, shared lock, whatever it might be? And again, we can see what wait events dominate, because obviously then helps you understand how you might tune your environment. We just scroll down a little bit further. We've got some pie charts, donuts, that again give you a sense of proportion. So you can see here that you're getting on for nearly 3/4 of the time is dominated by the top ranked statement. So that gives you an important clue as to where you could get the most performance gain. At this side, we've got the wait events. Now, the wait events are still probably somewhat still in work in progress. We're trying to sort of decipher various pieces of information that SAP has. And in fact, it's the same for all the vendors. Some make it easier for you than others. So that one, possibly the names may change a little bit as we go along, but this is the first cut of the wait events.
Sorry, on that top statement, what does it say? Like that purple, which is 75% of it. Like, what do you detect from that?
So this one, yeah, this one, and this is the ID, the 901, which you will see here.
Oh, got it.
Next to the text. We can't fit the text.
Yeah, okay, I get
something
it.
like that.
Okay.
So we give everything what we call a SQL hash.
Okay.
So it's our own hash value. Just for it makes it easier to reference it from various parts of the tool.
That makes sense. Thanks.
So we have a ranking here of statements, and obviously statement number one is by far the most dominant. We'll look a bit more in detail in a moment. We'll click into it. But there are other statements that are in the list that make a lesser contribution. And the general principle, obviously, is choose the top one as your starting point, unless you have some other information that context information. But we also have other tabs that help you decide on that context. So we've got a list of wait events, and for most of the products, not yet SAP, but if you click on that, it'll take you to our knowledge base to say what does it mean. So that'll be coming shortly as the documentation catches up with the software, usual thing. So most of the time is spent running, as far as which usually means using CPU. But again, that would be explained more in the help text. The applications are visiting 3 databases. NYC data is the most common one. This is where we've got our sort of rides database, but there are also some other databases. And you can filter by some of these things. So if you clicked on that, then it would only show you statements that belong to this database. And as it happens, because it's 90-something% of it, the list looks very similar to how it did before. If we just clear that and have a look at, we can rank by sessions. Again, you can see get down to see which individual session was executing the most. Again, it can help you with sort of something, real-time problems where you want to see who's logged in, where they're coming from. So most are coming from this particular IP address, 249. But there are other jobs as well. And we've got 2 users, system, and obviously got this sys statistics, which presumably runs background jobs. So you can filter by any of these criteria. So if you wanted to know all the statements being running by our test Apache JMeter script, then again you could filter, and again it probably look quite similar in this environment. We don't have a lot of variation in our traffic at the moment. So these tabs here are very useful for filtering and creating you a new list of ranked statements filtered by whatever criteria that you have there. Okay, so we've looked at the instance level, and just before I go, you can a couple of shortcuts. So you can go straight to instance settings if you want to. You can look at copy the URL and maybe give it to somebody else so they can see what's going on. You can create a snapshot, which is to remember the time frame, give it a name. And I don't know if we've got any. So you would, you'd give it a name, sort of, Instana demo, give it a description, and then decide whether you want to keep the detailed data. If you don't keep the detailed data, then it just becomes really just a lookup, a shortcut to finding that particular date range, that last hour on the 6th of February. If you do keep the data, then that data will be kept for as long as you want it. So if this was an important test run or production incident or whatever, you could record the snapshot, and then that'll be there for posterity for you to look at later. Anyway, let's now move on to the statement. So we'll look at the top statement. And so there's the text for it, the full text. Below it, we've got a number of execution plans that we may collect for it. Here we've just got the one, but if you had more than one, it would allow you to choose. We keep a kind of a continual background job that from time to time does a new execution plan, because obviously execution plans can change over time. So it's important to try and get the execution plan that was as close as possible to the actual execution of the statement, which may have been, yesterday or whatever, because today the plan may have changed. So just getting the current plan is not always sufficient. In this particular case, the plan hasn't particularly changed. And we have the steps here. So it's looking at the rides row table, which makes sense because that's what the statement says. And then on the right-hand side, we've got some detail about what the operator name is, what table it's operating on, schema, table size, expected rows, all that kind of stuff. The plan is very important from a tuning point of view. You want to understand what it's trying to do, whether it's doing an index scan or a full table scan or whatever. And so this can help you answer it. And obviously, if it changes over time, you can keep a track of whether you've got them. We can also look at the activity for the individual statement. It was kind of a dominating statement, so its profile will probably look quite like the instance level. So this is the effort time over time. If we did have some hosts, we could put underneath it, but we don't actually, so it's not going to work. But this would expand underneath here. So under sort of between the two sets of graphs, there'd be another graph that would be drawn, which would line up with this one, so that you could see how CPU utilization, say, changed with the effort of the statement. The weight charts again. as we've seen before, the weights, which database, and again, the context information as to, where that was running. We also have statistics. This is, if you remember, I said there were 85 different statistics that we could collect. We've only collected 6 or so, and these are them. And normally we include them because they've got the most popular ones like duration, executions, average duration, CPU time, and so on. But there are those other myriad ones that you could have, in which case this table at the bottom here would just sort of scroll off to the right. Actually, one thing I didn't show you, I should have mentioned. When you're looking at a step and you want to know more about it, you can click on the button at the bottom. Again, our documentation probably hasn't quite caught up with the software yet, but if you're not familiar what an aggregation on the table means, then you can look it up. Okay, I think that's probably a reasonable tour of the new functionality. There are a few things that we haven't yet done. We have done SQL statistics. So this is statistics for all of statements, which I just showed you for one statement. We do have database statistics. So again, a long list of things like active sessions, commit counts, and so on. The SAP provides a lot of executions, idle sessions, max connections, a lot of statistics at the instance level as well, which is, they vary from technology to technology, but the general principle is the same. If we had to host hooked up, we would get something like there. I don't think we've got any changes recorded at the moment, but we do capture change events. So if you've made created an index or dropped an index, created a table, modified a system parameter, things like that, they would be caught by that background batch job, and they would be listed here. I don't know if we've got any across the so this kind of thing where you've got also custom ones as well. So you can actually tell DBmarlin by sending an API event into DBmarlin that you've had a custom event, such as a configuration change, or you ran a test run, or there was an alert, and it would also include things like index creation drop. Because if you change something about the environment, such as the indexes or parameters, then that obviously could have a profound effect on the performance of the SQL statements, which is the sort of the bread and butter of what DBmarlin is about.